from School of Engineering and Technology Department, and welcome to our lab experiment. Let's enjoy and learn!
To procedure, our initial step was to construct a piping system using the necessary materials, which included a transparent pipe, a container, a dye container, a valve, a syringe, and a tube. Then, we first focus on the building the main container, which serves as the primary reservoir for the water. This container was fitted with a faucet or valve to regulate the water flow. To continue the procedure, we connected a transparent pipe to this bulb. This transparent pipe was crucial as it would be the section where the water flows, allowing us to visually observe the type of flow, laminar or turbulent. The transparent nature of the pipe enabled us to clearly see the behavior of the fluid as it moves through the system, thereby allowing us to identify its flow regime. laminar flow investigation, the valve was often only slightly to ensure a slow, controlled flow of water. Crucially, we also use food coloring into the water to make the flow patterns clearly visible. We allowed water to flow from the container through the transparent pipe into the graduated cylinder. Our goal was to collect precisely 200 ml of water in the graduated cylinder. We meticulously recorded the exact time it took for the 200 ml mark to be reached using a stopwatch. This time measurement was crucial for computing the flow rate and subsequently the flow velocity. Additionally, we measured the mass of the vapor containing the 200 ml of collected liquid. The procedure for the turbulent flow investigation largely mirrors that of the laminar flow with a critical difference in the valve opening. Here, the valve was often completely or widely, allowing for a much faster and more vigorous flow of water. Data and result. After completing both the laminar and turbulent flow investigations and gathering all the necessary raw data, 5 dimensions, masses of empty and filled containers, and recorded times for 200 ml collection, we proceed with calculation. The analysis of this computation allowed us to definitely characterize the fluid flow in the 5 under different conditions, successfully distinguishing between laminar and turbulent flow regimes based on both visual observation and calculated Reynolds number. To proceed the conclusion, the experiment demonstrated key fluid flow behaviors and pipes, particularly the behavior of laminar and turbulent flows, confirming the Darcy-Weisbach equation through measured pressure drops and calculated friction factors. These results are essential for engineering applications as they help in efficient piping system for water supply, HVAC, and industrial processes. Understanding flow characteristics ensures reliable, cost-effective system performance.